Good morning. So we just finished our unit on solving systems of equations, and we're going to start our next unit, Unit 10, on solving inequalities. So we're going to look at, for the first couple sections or first half of this unit, on solving inequalities with one variable, and then the second half of the unit will be solving inequalities with two variables, which mean we'll be graphing linear inequalities and learning how to shade those graphs for all the solutions that make it true. After this unit, we've got 2 units left. We have a unit on radicals, and then we will finish up the year with the quadratic formula, I believe, is where we're ending up. So there's not much left to go. I think you'll find what we're doing today and next time we meet fairly easy, because you solve inequalities just like you solve equations. It's just the graphing on the number line is a little bit different. All right, so our objective today is to solve and graph inequalities with one variable using all 4 operations: addition, subtraction, multiplication, and division. The solution of an inequality are any value or values of the variable that makes the inequality true. For example, if x is greater than 10, the solution is all the numbers greater than 10. And if we're talking about real numbers, that's a whole lot of numbers, because we're talking about rational and irrational numbers in between there. Okay, I'm going to quickly breeze through these properties, because properties of inequalities are the same properties we've already learned for equalities, equality, meaning that anything you add to one side, you do to the other. It's like when you are solving an equation, if you're adding 3 to one side, the left side, you have to add 3 to the right. Well, that holds true for addition, subtraction, multiplication, and division. Okay, so that basically takes care of our first page. Let's go into the second page. It says to solve an inequality, follow the same process you've used to solve equalities. For example, if I have x plus 7 equals 6, to get x by itself, I subtracted 7 and got x equals -1. So it's just showing it in set notation, x such that x equals -1. That's all it means. There's one solution. The solution that makes that true is when you plug in -1. So now let's look at x plus 7 is less than 6. If we subtract 7 from both sides, we get x is less than -1. This says x such that x is less than -1. There's infinite solutions. It's every solution smaller than -1. -1 is not included in that solution. Okay, so it's going to look very similar. You're going to be very used to this process. So there is a trick or catch when you multiply or divide inequalities, because when you multiply and divide by a negative, you must reverse the direction of your inequality symbol. Let me make this smaller. I had this a little bit bigger because I was doing some notes and you couldn't see them. Okay, reverse the direction of the inequality. Example, I'm sure you will say it's true that 5 is less than 8. That is true. But when both sides of the inequality are multiplied by -2, -10 becomes greater than -16, because 5 times -2 is -10, and -2 times 8 is -16. So the inequality symbol is reversed to make it true. Okay, so I've multiplied by -2, I switch my inequality. -10 is greater than -16. Likewise, 1 is greater than -4. But when dividing by -2, the inequality symbol is going to change, because now it's -1/2, and you're comparing it to +2. Okay, so when we do that, it's no longer true that 1 was greater than -4, but now we have to say -1/2 is less than +2. Okay? There's another example here. -7x is greater than 42. When I divide by -7, x becomes greater than -6. So you must remember to reverse the direction of the inequality symbol. Okay, there's some notation I want to make sure you know before we start graphing these on a number line. When graphing an inequality on a number line, it is always easier if the variable is on the left side. So that's just something that helps out. You can keep it on the other side, but sometimes it's confusing when you go to graph it on a number line. So that's important. The second thing is I want to go over some terms. If you have less than, hopefully you know this is the less than symbol. And graphing means that it is an open circle on, I've got all these on big. I thought I switched that one. Let's go to this one. Open circle on whatever real number that you are graphing. If it is greater than, hopefully you've recognized the greater than symbol. And it is an open circle also, but I forgot to mention when we did less than, you're shading everything to the right. You're shading to the right. This way, you're shading to the left. So the direction of your shading is what it's talking about. If you have less than or equal to, you're going to have a line below that less than symbol. It is going to be a solid dot. And that solid dot is still going to shade everything going in that direction. Okay. And then finally, let's go to here. If you have greater than or equal to, you're going to have a greater than symbol with a line under it. It's still going to be a solid dot, and you will be shading everything to the right of that. Okay, so let's practice. Solve and graph each inequality. Write your solution and set notation. Remember to reverse the sign of the inequality if you multiply or divide by a negative. All right, so let's look at a few of these. The first one, r plus 27 is less than 22. I want to get r by itself. I do that by subtracting 27. So I get r is less than -5. It's a less than symbol. So that means it's going to be an open circle. So when I'm graphing, -5 is going to be my biggest number. So I'm just going to go by an even integer all the way. Your graph, remember, it does not have to start at 0. You can go by 2s, you can go by 5s, you can go by 10s, just as long as you're consistent throughout each interval that you're marking. Open circle, and I'm graphing everything in this direction. And that's all we do for that, okay? I'm going to go to number 3. Number 3 says 3q is greater than -12. I'm going to divide by 3. And when I divide by 3, I get q is greater than -4. Notice I don't have to switch my inequality symbol because I did not divide by -3. It's okay that my answer is greater than -4, but if I would divided by a negative, I would have switched that to a less than symbol. So greater than -4, I might start at -4 being my smallest point and then go up from there. Open circle again, and I'm graphing. All right, let's do number 4. Number 4 is -10y is less than or equal to -60. To get y by itself, I'm dividing by -10. Since I divide by a negative, I am switching the inequality symbol. I'm going to put a little note here, switch inequality, divided by a negative. Okay, so this time I might start 6 there. I could have started whatever I wanted. I could have made that 4, 5, 6, start wherever you want. Okay, so starting at 6, it's greater than or equal to, that's a solid circle. Solid circle, and we're graphing all these real numbers. Keep going on indefinitely, our solutions to that. Okay. Let's look at another couple of these, and then the ones we don't do, I'm going to have you just look at them on your own. Let's do number, what do we have left here? Let's do number 5. X over 3 is greater than negative 12. I want to get x by itself. To undo division, I'm going to multiply. I'm multiplying both sides by 3. When I do, I get x is greater than negative 36. So over here, maybe I'm going to start this one and go by 2's. Negative 32, negative 34, negative 36 again. Just as long as you're consistent. I have to redo that because that's backwards. Negative 36, negative 34, negative 32, negative 30, negative 28. I was making them smaller instead of larger. All right, so I'm going to have an open circle, and I'm choosing all the values that are bigger than that. All the values that are bigger. Okay, so that's that one. Let's do number 9. Number 9. 4n plus 2 is less than 7n minus 13. You're going to subtract 2. We want to isolate our numbers together and our variables on the other side. And at the same time, I'm going to subtract 7n. So I get 4 minus 7n is negative 3n is less than, the 7n's are gone, negative 15. I'm dividing by a negative. When I divide by a negative, I switch my inequality, and this becomes n is greater than 5. So now this one, maybe I'll go 0, 5, 10, 15, 20. And it's an open circle because it's just greater than, and then I shade this way. Okay, I'm going to pause here. I'm going to give you the answers to these so that when you graph them, you will be able to check and see if you have the correct answers. So number 10 is r is greater than or equal to negative 4. Make sure you put a closed circle on negative 4 when you graph it. Number 7. Number 7 is v is greater than 4. Open circle on v, you'll shade to the right. Number 8 is w is greater than 5. That's also open circle, but it's everything bigger to the right of 5. And then number 6, k is less than or equal to 6. Closed circle on 6, and you're shading left. If you struggle with any of those, go ahead and message me, and then once you finish those, then there will be part 2, which is pretty quick. We're going to do a little problem solving, but go ahead and try these first, and then we'll come back together in a second video. Okay, I'll see you in a few minutes.